Hello, this is Mr. White, and this video is on the chain rule, part 3, including trigonometric functions. Something about trig functions just always seems to throw students off. Just when they're starting to get the hang of the chain rule, something about the trig function just messes with the student's mind. So let's tackle that here in this video. Here are the 3 exercises we'll be doing. And let's clear out these 2 and start on that first one. Find the derivative of g of theta, which equals cosecant of 1/2 theta times cotangent of 1/2 theta. Now, one thing we should always consider with trig functions before we jump into the calculus, you're noticing a recurring theme that very often we should ask, is there any algebra I can do to make my calculus easier? We should also ask, is there any trig that I can do to make my calculus easier? With that big wind-up, I'm going to admit that there isn't really in this case, but I would say that if this problem were different, let's say that instead of cotangent, let's say this were tangent instead. Then I would say there is absolutely something we can do to make our lives easier. Remember that cosecant is the same as 1 over sine, and in this case 1/2 theta. And if we're multiplying it times a tangent, isn't tangent just a sine over a cosine? And in this case 1/2 theta, 1/2 theta. We see that, wow, we could really make things a lot easier there. We could avoid the product rule and some other kind of messiness with that realization there. So be on the lookout for that. However, in this case, that's not what we got. We don't have a tangent, we have a cotangent. But look out for it. It's not always going to work. So what do we do here? We are clearly going to deal with the product rule then, right? And I say clearly, actually let me discuss one other possibility now that I've brought that up. If you really wanted to make this 1 over sine and then make this cosine over sine, and if you wanted to combine those and make this cosine over sine squared, and if you thought that would be easier for some reason, that is another option you have. I'm not going to do it here, but I encourage you to explore such possibilities when you're doing your assignment. Okay, now back to this one. Let's go ahead and do the product rule on this one. And one thing that that some students find helpful when doing the product, when the product rule and the chain rule are intertwined, is to just focus on one of those rules. So if you're feeling a bit overwhelmed, you might try this approach. G prime of theta, let's just focus on the product rule and try to ignore the chain rule for just this one step. The product rule says I'll do the second cotangent of 1/2 theta times the derivative of the first. But rather than actually trying to take the derivative of the first, let's write d over d theta of cosecant of 1/2 theta. So I'm just acknowledging that I still need to take the derivative. I haven't done it yet. That's what the d over d theta tells me. Plus the first times the derivative of the second. And I'm going to do the same thing. Cosecant of 1/2 theta times d over d theta of cotangent of 1/2 theta. So again, that was focusing on just the product rule alone. And now we can take a breath and then in the next step focus on the chain rule. So it's the chain rule because we've got a function, a 1/2 theta, plugged into cosecant here. So let's tackle that. And I've just instituted the convention I've developed in recent videos of making the outer function green and the inner function red. So let's focus on this and derive the outer function. So what's the derivative of cosecant? That would be negative cosecant cotangent, right? So negative cosecant of blank cotangent of blank. That's the derivative of just this cosecant right there. And let's plug in the 1/2 theta in both blanks. 1/2 theta, 1/2 theta. And then we need to multiply all of that times the derivative of that inner red function. So all of that gets multiplied by 1/2. That is the derivative of cosecant theta, cosecant of 1/2 theta. And that is going to be multiplied by this cotangent of 1/2 theta in front. So let's not forget about that, cotangent of 1/2 theta. I'm going to put this all in parentheses as well. And now we need to turn our attention to the second half of the product rule. And clearly I'm not going to get this all on one line, so I'm going to go on to the second line here. So I'll put equals, and then I'll go ahead and write this part. I will move on down to here. All right, let me clear myself a little space there. Okay, let's again focus on the derivative part. Let's take the derivative of the cotangent, the outer function, and that would be negative cosecant squared. So negative cosecant of blank, and that's squared. And let's plug in the inner function, and then multiply times the derivative of the inner function, which is exactly what the chain rule tells us to do. And so we have just completed this derivative of cotangent of 1/2 theta. Let's take that result and multiply it times the cosecant of 1/2 theta. Cosecant 1/2 theta, and that's all being multiplied there. And the calculus is over, and now it's just time for some algebra and trig. And we're going to have to be careful here. Let's try to clean this up. Let's try to combine some things. Notice that it may be tempting to look at these 1/2s, to look at 1/2, 1/2, 1/2, 1/2, and ask ourselves, can I multiply any of those? Well, not really, because 3 of those 1/2s are embedded inside of trig functions. This 1/2 is inside a cotangent. This 1/2 is inside a cosecant. This 1/2 is inside a cotangent. This is the only 1/2 that's off there by itself. So be careful. Just bring that last 1/2, this one right here, out to the front, and we'll say 1/2. Oh, there is a negative right there, so let's make that negative 1/2. Let's see, we've got a cosecant of 1/2 theta. And it is being multiplied by a cotangent of 1/2 theta and another cotangent of 1/2 theta. So that's going to be cotangent squared 1/2 theta. All right, let's address the second half of that now. See, once again, we've just got a single 1/2 here and a negative sign. So let's do another minus 1/2. And then we've got cosecant 1/2 theta and then cosecant squared of 1/2 theta. So that's going to give me cosecant cubed of 1/2 theta. Now, one of the tricky things about trig functions is that it's sometimes hard to tell when you're done. I would say we definitely should factor out what we can algebraically. So let's at least factor out the greatest common factor between these two terms, and that would be, looks like negative 1/2 cosecant of 1/2 theta. And if I factor that outside, some big parentheses here, what goes on the inside is going to be cotangent squared 1/2 theta. Let's see, plus cosecant squared. Okay, and this function was g of theta, so this is g prime of theta. And if a student were to stop here, under most circumstances, I'd say, you know what, I'm okay with that. We can call that done. I will point out, though, that for comparison to the back of the book, or for trying to choose a multiple choice answer, which may not match this, or if you go onto one of those computer services on the internet like Wolfram Alpha, you very well may not see this. So just a couple thoughts to consider of directions you may go. You may want to look at this and think, hey, how can I combine these at all, if possible, with my Pythagorean identities, right? At that point, you may come across some of your double angle identities that may allow you to combine this in more concise ways. So again, there are other options. I'm going to basically call it done here and invite you to explore. And especially when you're doing your assignment and you check against the back of the book, do make that extra effort to confirm whether your answer matches the back of the book. I'll just show you real quickly that when I went to Wolfram Alpha and wanted to check to make sure I was doing, that I didn't make any mistakes, let me show you what result they got. So look at that. At first glance, it doesn't look anything like what our answer is, but I have confirmed that it really is the same thing, but it may surprise you that a negative 1/2 here, that there's a negative 1/4 here. Notice that this is just cosine of theta. It is not cosine of theta over 2. And where did that cosine come from in the first place? Again, look to your trig identities. Be willing to look to your trig identities to resolve such questions. All right, let's go on to the second one. Find the derivative of the function p of t equals 7 sine to the 4th power of pi t. Wow, this one always causes trouble for students. And typically, students don't recognize that this is a function within another function. This is a double chain rule, if you will. That's the first thing you got to observe here. So let's help ourselves by rewriting this. Again, no calculus yet. Let's just rewrite this as 7. And even though it's typical on paper to write sine to the 4th power of pi t, let's write it in this way. Sine of pi t, and then that's all in parentheses raised to the 4th power. And even though this is not the more conventional way to write it, when you write it in this way, it's a lot easier to see how the chain rule is going to fit in here. Now, I just did my familiar convention of the outer function being green and the inner function being red. But again, we've really got embedded inside that inner function, we've got another function plugged into the sine function. So let's make that one blue. A blue function within a red function within a green function. And let's just chain our way on through this problem here. So let's start with the p prime of t. And let's focus on the green outermost function. 7 times blank to the 4th power. Again, I invite you to either cover up or right off the side if it helps you. Really focus on 7 times blank to the 4th power. And that's going to give us, if we derive that, that's going to give us 28 times blank to the 3rd power, right? Now let's move this back on inside and also put it over here. Again, we didn't derive it yet, but what we need to do is then multiply all of this times the derivative of this. So I could try to do it all in one step, but I'm going to say times the derivative, d over dt, of all that. Okay, pause if you need to. Make sure that is totally clear that we have just applied the chain rule to only the outermost function, and we still need to tackle this. All right, let's go ahead and do so. So let's look at that as a chain rule problem in its own right. If it's helpful, let's move the innermost function out, and let's just derive the outermost function, which in this case is the red function. And when we derive that red sine function, we're going to get cosine of blank, right? Let's move the inner function back in. And again, it goes down here too. And then we need to multiply all that times the derivative of that inner function, which in this case is easy enough to do. I'll just do times pi. So let's not forget all the stuff that preceded it. Let's not forget that 28. See, parentheses to the 3rd, and then inside of that is plugged a sine of pi t. All right, and all that's left is to combine all of that in any way we can. So let's see, there's not a whole lot we're going to be able to do with that. We'll take the 28 and the pi, 28 pi. We'll take that. And let's go ahead and write it in the shorthand way, sine cubed of pi t. And then finally times this, cosine of pi t. And that is our derivative, p prime of t. I often hear the comment that I know it looks easy when I do it, or I hope it looked easy when I do it, but yet do expect that you'll have some difficulties when you try it on your own. Just really focus on the methodology I was trying to emphasize here, and be willing to work through the bumpy parts of this road. All right, let's go on to the last example, the last exercise. I like this last exercise. Find the derivative of y equals sine of the fourth root of x plus the fourth root of sine of x. Because right side by side, we've got two elements, two functions here that look very similar to each other yet, and they do have the same elements, but they're not the same, of course. So let's see how we'll tackle that. Let's rewrite first. We're not doing any calculus here. Let's just rewrite this in a more calculus-friendly way, and let's ask ourselves, what is the outermost function of this first piece of the puzzle here? And that would be sine of blank, correct? Sine of blank. And what function goes inside of that? Well, just x to the 1/4 power. That's our fourth root of x. So this is not a chain rule within a chain rule. But let's go on here. Let's look at the second part. And this time when we ask what's the outermost function, the radical is on the outside of the sine function. So the outermost function is blank to the 1/4 power. And then plugged into that is the sine function. So again, all the same pieces of the puzzle, but just you might think of this one as f of g of x, whereas this is g of f of x. All right, and let's just carefully chain rule both of those. Now we're doing calculus, so now we'll say y prime equals. And if we look at this first piece, and we derive the outer green function, the derivative of sine of blank will be cosine of blank. Inside of that, I'll just write the inner function, but then I'll multiply that whole thing times the derivative of that inner function, and the derivative of x to the 1/4 is going to be 1/4 x to the negative 3/4. Plus, if I derive the outer function here, the outermost function was blank to the 1/4, so that would be 1/4 blank to the negative 3/4. And what goes inside of there? Well, sine of x. But then that all gets multiplied times the derivative of sine x, cosine x. Now surely we must be able to algebraically simplify that in some way, right? Maybe not as much as one might think. It's a little bit frustrating to students often to find that there's not a whole lot we can combine there. Let's see what we can do. Let's see, looking at that first expression, let's go ahead with that convention that we will not have any negative exponents. So let's go ahead and write in our numerator cosine of x to the 1/4. And then in the denominator, there's going to be a 4, right? So that 1/4 there means that there's a 4 in the denominator. And notice that this x to the negative 3/4, that really belongs in the denominator as well. That's x to the positive 3/4 in the denominator. Pause if you need to. Make sure you see how I've simplified this first term. And then let's go on to the second term. We've got a fraction again. Once again, I've got a 4 in the denominator. And this time I've got sine of x to the negative 3/4 power. That's the same as sine of x to the positive 3/4 power in the denominator here. The cosine is not being raised to a negative exponent, and it is not already in the denominator, so I'll just put cosine of x. And unless I felt compelled to write this all as one term and do the common denominator thing between this piece of the puzzle and this piece, I'm going to just call it done. I don't feel compelled to do that in this case, so let's just call that done. However, if this were a textbook problem and I looked in the back of the book, I would ask, of course, that you try to resolve this answer with whatever differing answer or allegedly or apparently differing answer you may see in the back of the book. I would venture to say that they were actually the same thing if you just press on a little bit.